2.1.2 is asking us to use our rule to calculate the 15th term. So our rule is what we just calculated here. It is Tn is equal to negative 3n plus 13. That is our rule. So they want us to use that rule to calculate the 15th term. Now 15th term means the 15th position, in other words T15. So I can insert, since I have a rule to calculate any term, I can say T15 is equal to, and then wherever I see an n in my rule, I will replace it of course with 15. So that's negative 3, and I can substitute 15 plus 13, and this is where I use my calculator. So negative 3 times 15 gives me negative 45, plus 13 gives me negative 32, and that is my 15th term done. 3.1 is a throwback to term 1, and it deals with having to calculate or determine the highest common factor of two numbers. In this case it's two numbers, so and those numbers are 198 and 3960. Of course we need to throw these numbers onto a ladder. These are two composite numbers, and we know that we can break up any composite number into a product of the prime factors, and that of course will then allow us to calculate that highest common factor between the two numbers, or of the two numbers. So if I take 198 let's just do that, and then 3960, and let's go. So we've got the smallest prime number that can divide into 198. So that's the process. We take the smallest prime number and divide it into the number on the left here. So that is 2. So 198 divided by 2 gives us 99. So that's 99. And then again you need to play around with your prime numbers here and choose the right one. So this time it will not be 2, because 2 cannot divide into 99. And our next prime number then would be 3. So we know that this would be 3, and divide that by 3, and 99 divided by 3 is 33. And of course the number again here will be 3, and 33 divided by 3 is 11, so that would be 11. And the smallest prime number that can go into 11 is 11 itself, so that will be 11, and 11 divided by 11 will be 1. So the smallest prime number that can divide into 3960 would be 2. So 3960 divided by 2 gives us 1980. Here again it would be 2. Divide that by 2, I get 990. And then there it would be 2 again. Divided by 2 gives us 495. And here our smallest prime number will not be 2. It will be, let's try 3 first. Oh, sorry, wrong button pressed there. 495 divided by 3 gives us 165. So it is in fact 3, because when the last digit in your number is 5, it could be 5 of course, but we need to test for 3 and 5. There are rules for divisibility that you can learn, so that you can choose the correct one. But we can just play around with 3 and 5. It takes 2 seconds to do that. So our smallest prime number here is 3, so 495 divided by 3 is then 165. Again, can 3 go in there? Yes, it can. So it will be 3, because it will not be 2. 165 divided by 3 is 55. And here now, 55, if you know your multiplication tables, a bit better, you'll know that 3 cannot go into 55. But let's say you didn't know, you'll obviously try 3 again and find that, it's not that. So let's go back. So the next prime number, of course, will then be 5. And you'll find that it is 5. So that's 5. Of course, you are expected to know at the very, very, very least, the first 10 prime numbers, so that you're able to sort of work through them a lot quicker. So 55 divided by 5 is 11. And then, of course, we saw earlier that 11 is the smallest prime number that can go into 11, of course. And then 11 divided by 11 is 1. Just extend that. And there we go. So let's get back to what we're here to do. Of course, this will go a lot quicker. It should go a lot quicker when you do it yourself. You should not take this long. 198 is equal to, so what this is that 198 is equal to 2 times. Now there are 2 3s over here. So that is 3 to the power 2. I'll just go straight to exponential form, and then times the 11. Okay, there are no pluses involved here. Some of you are still writing 2 plus 3 to the power 2 plus 11. That is very, very, very incorrect. Please, it is product, so 2 times 3 to the power 2 times 11. And in the same year with 3,960, we've got 3,960 is equal to, I've got 3 2's, so that's 2 to the power 3, and I've got 2 3's, that's 3 to the power 2, I've got a 5, and I've got an 11. Okay, 1 is not included. Please, 1 is not a prime number, so it cannot be a prime factor. It is on the left or on the side of the ladder that is not the part of the list of prime factors. So please do not include the 1. Now we are not finished. We still need to determine the HCF, so the highest common factor out of these sets of factors. So out of these guys, what are the common prime factors here? So 2 is common. The factor of 2 doesn't matter now yet how many 2's, but the factor of 2 is common. You can see that 3 and 3 is common as well. And you'll notice that the 5 is not common, because the 5 only appears in the 1 set of factors, but then the 11 is also common. So those are the common factors. But now, factors meaning it's division here. So how many factors of these are common? In fact, in other words, how many 2's are common to both numbers? Now, in 3,960 there are 3 2's, and in 198 there's only 1 2. So 3 2's is not common to 198, because 198 only has 1. So the only number of 2's that is common to both numbers is 1 2. So we will choose 1 2 only. Times, in other words, the 2 with the smallest exponent. That's basically what you're choosing. Then for the 3's, 3 to the power 2 is common to both. So we can take that entire 3 to the power 2, because 3 to the power 2 is the highest number of 3's that can go into the 2 numbers. And that is again what we are doing here. We are checking what factors are common, and then what is the biggest amount of factors that is common to both those numbers. Then with the 11, we've got 111 for both, so it is 111 for both. And this is then a product of the factors that are common, but that is not the highest common factor. The highest common factor is a number, so we need to simplify this and actually get an answer. So 3 squared, of course, is 9. If I can so that is actually 2 times 9 times 11. So 2 times 9 times 11 gives us 198. So your highest common factor is 198.